Lafayette HE30 et al., 1960–1966. Trio 9R59 JR101, Lafayette HE30, KT320, H230, KT340. This is the documentation of the experience of a hobby project, available in video and in written form, made with the hope that it could be helpful to others. See the links in the description. But any comment that could help me to improve my practice is also welcome and appreciated. This is a popular ham radio receiver of the 1960s, made in Japan by Trio Kenwood, which appeared in the world market with different brands and different names, but with the same chassis, case, and schematics, built by the factory or sold as a kit. The item under restoration was rebranded by the American Lafayette with the name HE30, and it was made in particular for the European market, with a proper power transformer for 230-volt AC. In fact, at that time, the brand Lafayette was well known in Europe. This is a very decent vintage ham receiver built with very good quality components, but with a minor issue in the BFO oscillator that can be easily solved in the process of restoration. It is remarkable that, in a period of time in which cost reduction in electronic products was a necessity, this receiver was still produced with higher standards. It is noticeable that the chassis was still made with the tube names carved on it, that the intermediate frequency coils were adjusted via metal stub, instead of having to turn directly the fragile ferrite core with the fear of breaking it. To make a comparison, here are the IF transformers used in the Hammarlund HQ100. They are very fragile and, by now, most of them have developed silver mica disease. The best documentation for this receiver is the one made for the edition sold as a kit. For example, one could find the assembly manual for the Lafayette KT320 or KT340 from Bama, the Boat Anchor Manual Archive. This is the original schematic diagram with minor retouches, in particular the switches 1, that in the original schematics may seem a bit misleading. By the way, here is how the switches 1 is supposed to be connected in its various positions. Please notice that, assuming that the receiver is used standalone, without a transmitter, the terminal 1 and 5 of the socket J3 should be shorted together, usually with a dedicated external plug. The receiver arrived in a fairly good condition and almost completely original. Only the resistor, R23, appeared to be something that was replaced along the way. After having cleaned the chassis, also treating it with a rust remover in a few bad spots, before proceeding with anything else, it seemed appropriate to take care of ensuring a ground connection to the chassis, also including an additional fuse to protect both power lines against shorts. The additional fuse has been installed inside the chassis. The original power cord was made of only 2 wires, and having to replace it with a 3-wire power cord, the original strain relief, or cable glands connector, could not be reused. In place of the original strain relief, 3 grommets have been used. The first one as large as the hole, 2 smaller grommets on the wire, one inserted before and one after the hole. The cord end inside the chassis was secured with 2 cable ties. The external grommet has been pushed towards the cord end, remaining outside the hole. The 3 grommets have been glued with super glue to themselves, to the power cord, to the chassis. In the end, the cord could not be pulled, pushed, nor turned. after having taken care of the power cord, also the capacitor C28, the depth capacitor has been replaced. Then the voltage selector has been glued to the position of 230 volt AC because the receiver will remain in Europe, and it would be too easy to switch it accidentally to 115 volt without even noticing it. Most of the tubes in this receiver are held in place by retainers hooked into the chassis. When a tube is removed, the corresponding retainer tends to sink under the surface of the chassis. If the receiver is turned on with a loose retainer, there is a chance to create a short circuit. When a vacuum tube is put back in place and the retainer is pulled back to hold the tube, there is a chance to inadvertently hook a wire under the chassis, possibly removing its insulation, and therefore creating a short circuit. This receiver, in all its incarnations, uses a few special paper capacitors in oil. This piece of information comes from an advert from Lafayette. These capacitors were of very good quality at their time, but today they are all electrically leaky. Testing them with an LCR meter, they seem to have an excessive capacity, about twice their nominal value, or even more. The quality of the oil is not known, and it is advisable to avoid opening them. There are only 3 electrolytic capacitors in this receiver, which should be changed without hesitation considering the age. The filter capacitors are contained in a single can, and for this restoration that can is emptied and used to contain the new ones. One might be tempted to increase the value of the filter capacitors, but that could be a bad idea. This receiver uses a rectifier tube that can be either a 5CG4 or a 5Y3. The first filter capacitor at the output of a 5Y3 can have a maximum capacity of 10 or 20 microfarad depending on the manufacturer. Unfortunately, no analogous information is available for the 5CG4. Anyhow, assuming that the value of 40 microfarad used by the manufacturer of this receiver is okay, possibly because of the DC resistance of the output winding of the power transformer, increasing this value could compromise the rectifier tube, blowing the cathode bond. Therefore, considering that a value of 40 microfarad is not available nowadays for the first filter capacitor, a value of 33 microfarad has been used, while for the second a value of 47 microfarad has been put in place. The weak point of this receiver is the SSB circuit, which is the same as the Q multiplier when it starts oscillating. When the receiver is set to activate the Q multiplier, B4 corresponding to a 6 of E6 is connected to the B+ and to the output of V2 corresponding to a 6BE6. Then the potentiometer R26 is used to change the bias on the grid. There is a point in which V4 starts oscillating, following the frequency that is received from the grid. Reaching just before that point makes the effect of amplifying the signal, also improving the selectivity. When the receiver is set to use the SSB oscillator, the switch that connects the grid of V4 is open and the potentiometer R26 is shorted. Therefore, the cathode resistor for V4 is reduced to 3.3 kilo ohm, where theoretically the circuit should start oscillating at 455 kHz, tuning with the variable capacitor C31. The signal generated by the BFO oscillator is still loosely coupled, even though the switch is open. If the switch were closed instead, the signal received by the first intermediate frequency transformer would be overwhelmingly strong and useless. The problem is that on most of these receivers, Having now a used tube 6 of E6, the oscillation does not start. To solve the problem, the value of R10 could be reduced to about 1.5 kiloohm, and a capacitor of about 10 nanofarad could be put in parallel with R10. For this restoration, both things have been done, but it is not known if that could have undesired consequences in that circuit. So, if you are following along, you are doing so at your own risk. What you see here is a test in which the BFO and Q multiplier are finally working.
Tarihi çektikçe okumaması gerekiyor. Belki tarihin içine daha düşünce bahsedildiği söylemiş olmanın görevinde bu konu daha kolaylaşır. Bugün gelinen noktada bu yolculuk konusunda ölüm başına farklı söylemişlerin bu süreçlerde olması bu sözü değişen geopolitik dinamikler yansıtılabilir ama
There is an enclosed area containing a few components of the Q multiplier and BFO circuit, which is very difficult to access. The original schematics show a dashed line around the whole Q multiplier and BFO circuit, which might be misleading because it might suggest that all of them are contained in that particular area. In fact, only a smaller set of components is actually contained, and in most of the cases, there is no need to access there. The writing on the dial glass of the unit under restoration appeared significantly deteriorated. This receiver has been, and still is, very popular. Therefore, one could easily find a replacement from a specialized old radio parts seller. However, for this restoration, the original dial glass has been scanned and redrawn with the help of a vector graphic drawer. The size in millimeters of the whole dial glass is 290 by 100. A better resolution picture of the redrawn dial scale is available in the written documentation that comes along with this video. For this restoration, instead of trying to reproduce it on the actual dial glass, the dial scale has been printed on cardboard, sprayed with clear lacquer and attached behind the dial pointers. Consequently, the original printing on the dial glass has been completely removed. As for the dial strings, they have not been touched, because they still seemed tense and in fairly good condition. On the other hand, if they had to be replaced, that would be complicated because one should operate from the side that is facing the chassis. At this point, the receiver is already working, but still needing a full alignment. This procedure starts from the intermediate frequency transformers, which should be all tuned to 455 kHz. The radio should be configured for receiving AM with the IF gain set at about 75%, the automatic volume control and the automatic noise limiter turned off, and also the local oscillator completely disabled, removing the vacuum tube V3. A 455 kHz AM modulated signal should be applied at pin 7 of V2, corresponding to grid 3. During the alignment, the intensity of this modulated signal is reduced to a level that is just sufficient for the correct alignment to avoid overloading the system. The signal can be read across the loudspeaker, or a dummy load connected in place of the loudspeaker with an AC voltmeter. The intermediate frequency transformers T4, T3, and T2 are adjusted in this order, aligning first the secondary winding, then the primary, for each transformer. The secondary winding is accessible from above the chassis, while the primary is accessible from under the chassis. This alignment should be repeated, possibly reducing the intensity of the input signal, until no relative improvement can be obtained in the output. After the alignment is completed, the stubs could be sealed with some wax, warming up a tea light, and using a small brush to apply a little amount of liquid wax. It is possible to verify the IF alignment using a visual method, even if only very cheap digital equipment is available. In this example, a non-modulated slow sweeping signal is applied in the same way that it was done for the alignment described in the previous section. However, this time the AVC is activated and its line voltage is read with the oscilloscope configured for DC reading. The time base of the oscilloscope would be set accordingly for a very slow scan. For this reason, only a digital oscilloscope could be used. However, one should be careful if they wanted to repeat the same experience, because if the oscilloscope probe is connected inadvertently to the wrong place, the scope could be severely damaged or simply destroyed. Considering that the more negative the AVC line is, the higher is the intensity of the signal. The curve generated on the oscilloscope screen appears flipped upside down. After the IF chain, it is possible to align the BFO frequency, still without the oscillator tube V3, but setting the radio for Q multiplier and the variable capacitor C31 half meshed. Middle position if the knob is installed correctly. In this case, at pin 7 of V2 is applied the same signal at 455 kHz, but not modulated. The coil T6 should be adjusted to the point in which a 0-beat signal is obtained, also corresponding to the minimal reading on the voltmeter. This receiver has 3 stages in the RF section: the antenna, the mixer, and the oscillator. The names associated to the coils and trimmer capacitors involved in the RF alignment contain a reference to the section where they belong. For example, the following coils are used for tuning into the lower shortwave band. LO3 is in the antenna section. LM3 is in the mixer section. LO3 is in the oscillator section. The alignment starts from the lower frequency band and progresses up to the higher frequency, but after some initial settings, it is meant to be executed with the bottom panel installed. Before proceeding with the receiver turned off, it is advisable to remove the seals, verifying that the adjustments are free to move. The detailed procedure is described in the original documentation, but is also available in the written documentation that comes along with this video. In short, the vacuum tube V3 should be put back in place, if that has not been done already. It is verified that the dial indicators are correctly placed on their dial cord and are able to travel the entire extension of the dial scale. The antenna terminal A2 is shorted with the terminal E corresponding to the chassis ground. Then the receiver is turned on and set like in the picture, where the band spread indicator is aligned to 100 on the log scale. Please notice that the variable capacitor of the antenna trimmer should be half-meshed. The required modulated signal is loosely coupled with the antenna input. All the adjustments are done seeking the relative maximum output signal. If possible, it is important to verify that the actual oscillator frequency is above the one of the signal that is used for the alignment. Here you can see the whole RF alignment 20 times faster, but done without the bottom panel on top. Consequently, the alignment has been repeated later with the bottom panel in place. What takes a lot of time is the continuous need to change the frequency on the signal generator and on the receiver dial. After the alignment has been completed also with the bottom panel in place. Like for the IF transformers, also the coils and the trimmer capacitors of the RF section have been sealed using wax. The cabinet of the item under restoration appeared externally in relatively good condition, but inside the original paint had been damaged by the heat of the tubes, and a lot of rust developed there. Not having a sandblaster available, the cabinet has been submerged in vinegar for some days until the rust and the old paint was removed. Then the cabinet parts have been cleaned and washed with soap to remove the residues of acid. Unfortunately, this process also removes the zinc coating if there is any. So once the metal parts are taken out of the soapy water, they must be dried very fast and painted immediately. A first coat of zinc paint has been applied, then the final paint on top of it. This receiver was built using imperial screws, in particular UNC 440 and UNC 832. Even though they were stainless steel screws, those used externally have been replaced during the restoration because they were somehow discolored. Here is the casualty list. This receiver arrived without the external loudspeaker, so a custom loudspeaker has been made for the purpose. However, with this one, the sound quality is not very good. The test starts from the higher frequency band and proceeds down, ending to the broadcast band.
Le référence universelle proposée par la Chine et soutient
care arată trece transfer la internet și aplicat tocmai în
hace 9 años fue abatida.
For those who were first enlightened and have tasted
ሰላማዊ ሆነ የስድብ ቅጣት የደረሰበት
Nouă ediție a emisiunii Muzică 100% numai la Radio
took out 3 military vehicles, including tanks.
Plus, we're getting more information from the site of the deadly train crash in India.
It hit the stationary freight train at 80 miles per hour. Ce caută o femeie și...
The test is done only with an indoor antenna, but in the 40-meter band, it is possible to listen to some ham radio communication.
Vittoria 5 anche per te un punto. Non è Simone, ok Simone, ciao. 5.000 miglia, chiamata di prova 1.000 miglia, Z2 Bravo, Victor Charlie, Z2 Bravo, Victor Charlie, chiama 1.000 miglia. Ja, prima, ja, ich bin auch und Joris, das heißt 85 und ich habe auch Probleme mit dem Schreiben. Grazie a te Fabrizio, benissimo di mio il nome per te reale. Fabrizio, 25 di visti anche questa mattina. Звоните тест вызова.
Vieni Ferti.
Katika maisha ya mwanadamu
If you would like to contribute to this project, donating old electronics equipment or old radios in whatever condition they might be, provided that you do not feel any attachment, that could be helpful for my next restoration documentation and video production.
confronti delle minchiate. Quando...
Produced in collaboration with campus community radio station CKUW 95.9 FM in Winnipeg, on the traditional lands of the Anishinaabe, Innu, Oji-Cree, Dene, and Dakota, the birthplace of the Métis Nation and the heart of the Métis Nation homeland. The show is podcast on radio stations throughout Canada and the United States. I'm your host, Michael Welch. The show first goes to air on the day